A sausage called Würstchen is the fastest new model in image generation and better than midjourney. Creating images from text descriptions is like turning words into pictures, and it's a tough job for artificial intelligence. It's like asking a computer to be an artist, but this task needs a lot of computational power and costs quite a bit to train AI for it. Plus, we want these AI-generated images to look really good. Now, enter Würstchen, the problem solver. It's not your average AI model. It's special. What makes it unique is how it works. It has a two-step approach. In the first step, it uses something called VQGAN, and in the second step, it uses a diffusion autoencoder. Together, these two steps turn super compressed images back into detailed pictures. In simpler words, we call them the decoder, because they decode the images. Imagine you have a giant image, like a 1024 x 1024 pixel photo. It's huge and would take a lot of computer power to work with. Now think about making it much smaller, like squeezing it down to just 32 x 32 pixels. This compression makes it way easier for computers to handle. Most methods out there use a relatively small amount of compression, maybe 4 to 8 times smaller. But Würstchen takes compression to a whole new level. Instead of just 4 or 8 times smaller, it goes down to 42 times smaller. That's like shrinking a big picture down to a tiny fraction of its size. Now for this, Würstchen uses a clever two-step process to do this extreme compression. First, there's stage A, which does the initial crunching, and then stage B, which refines it even more. Together, these stages are like the magicians that make the big image disappear into a very tiny box. But after all this squeezing, there's a third model, stage C, that learns how to understand this super compressed image. This training is way faster and cheaper than what other top models need. We call stage C the prior. Another important thing you should note is that Würstchen isn't just fast, it's lightning fast. It can create images way quicker than models like Stable Diffusion XL, and it's like a memory-saving champion too. For those of you who don't have super powerful A100 GPUs just lying around, you'd be over the moon to hear this. Let's put it in simple terms. Say, you're baking cookies, and you have 2 ovens. One oven takes hours to bake a batch of cookies, and it needs a massive kitchen. The other oven bakes cookies super fast, and you can even use it in a regular-sized kitchen. That's Würstchen, and the best part about all this is that it definitely doesn't cost as much to train. The first version only needed 9,000 GPU hours, which is like a fraction of what it takes to train other models. This makes it easier for researchers to try out new ideas, and it opens the door for more organizations to join the training fund. Even the second version, which works with much bigger images, is still 6 times cheaper than the older model. For now, let's look at how this sausage was made. When creating Würstchen, many important decisions had to be made, especially when it came to setting up and training its different stages. Let's dive into some of the key choices. Image encoder. Selecting the right image encoder was crucial. It had to meet 3 important criteria. First, it should have been trained with a good understanding of various types of images. Second, it needed to be a small and efficient model to speed up training in stage B and C. Lastly, its feature dimension was vital. Not too small to lose image details, and not too large to slow down the process. Model type for stages A and B. Würstchen uses the Paella architecture for stage B. This choice was made because it can efficiently handle quantized data and doesn't require many inference steps to create images at a resolution of 128 over 128. But, theoretically, a diffusion model could have been used as well. Model type for stage C. Stage C requires a model capable of working with continuous data, which is different from stage B. So, a latent diffusion model was chosen. While diffusion models need more inference steps, it's feasible within the context of a denser latent space. These decisions were super important in shaping how Würstchen processes and generates images efficiently. But of course, it's a new model. There has to be downsides. Let's just say in a few experimental setups of the model, there have been a few challenges. One major issue arises when the model tries to generate images in stage B at resolutions higher than what it was trained for. This sometimes leads to repetitive patterns in the generated images. It's possible that this happens because the model struggles to interpret larger images properly. In fact, the problem seems to be related to how the conditioning mechanism works, where the efficient net embeddings are injected through cross-attention. This process flattens the embeddings and removes their two-dimensional positional bias, making it hard for the model to generalize well to varying resolutions during inference. What's more is that the current Würstchen design shares common limitations with models conditioned solely on clipped text embeddings, such as stable diffusion. These limitations include difficulties in rendering text and dealing with complex scenes. But it's important to note that this model's relatively low computational demands make it easier to iterate and experiment with the model's design more quickly. So despite some challenges, the sausage makers are continuously working to improve and address these issues. Together, Würstchen's cutting-edge technologies are reshaping the world of text-to-image generation. Its unique two-stage compression process, unmatched spatial compression capabilities, and swift adaptation to different image resolutions combine to create an AI model that's changing the game. For those of you who are ready to tackle the toughest AI challenges, this technology opens up entirely new horizons. Whether you're running a tech business or just passionate about AI, Würstchen holds the potential to take your projects to a whole new level. It's worth exploring how this remarkable advancement can elevate your AI ventures.